Hello, everyone. Good morning, good afternoon, good evening. Thank you so much for joining us here for our latest CCNA Prep session. My name is Rigo Villa. I'm one of the community managers on the Cisco Learning Network, and I'll be your host today. Before we dive into all the fun stuff, I just wanted to take a brief moment to talk about the CCNA Prep program and also cover a couple of housekeeping items. If you are joining us for the first time, the CCNA Prep program provides a series of live sessions that are led by subject matter experts. We'll get to explore the latest exam topics, offer opportunities to test your knowledge, and we'll also share resources to help aid you in passing the exam. And speaking of the resources, we do have some supplemental activity files for Cisco Modeling Labs and also for Packet Tracer, which can be downloaded at any time. You won't need them to enjoy today's session, but they will be very useful for practicing on your own. And we're going to be sharing the resource links with you all, so we've got you covered there. Also, if you're tuning in but have not officially registered for the program, I do encourage you to do so by scanning that QR code on your screen. This will ensure that you're notified of the upcoming events, access the resources, and you can also be notified when the sessions become available on demand. Now, I just want to address the Q&A and quiz questions for the event. So this will be an interactive session, and you can participate in our quiz questions. You can also submit questions and you can also access the resources via the Slido link. Uh, if you still need to log in, you can go ahead and scan that QR code on your screen, or you can also do so on your live streams page. Last but not least, at the end of this event, we are going to be launching a Slido survey, and we would really appreciate your feedback about today's session. And with that said, I am now going to take a moment to welcome back our esteemed speakers. We have lead content advocate Patrick Gargano, and joining him is principal engineer Hank Preston. They are both going to be leading us through the presentation today, covering the Syslog detective, unraveling network mysteries. Welcome, guys, and thank you again for joining us here to present this session. How are you today?
Well,
Good,
it's a
Rigo.
pleasure.
Yeah,
I feel like this season has been like an instance of where in the world are you? So Patrick, we
yeah.
look behind you. You've got moose on the wall, footprints over your corner. Where the heck are you coming from
I'm
today?
I'm deep in the Canadian Rockies for the Easter long weekend. We've flown out to Banff, Alberta, Canada, for some snowboarding. Dropped off our son on the hill earlier this morning. Made it back to the Airbnb. Parked myself in front of all the moose, and I'm ready to talk about some Syslog detective action here. A bit elementary, my dear Watson, I guess is what we should be saying.
Ah, fantastic. Well, thank you for it. Sounds way more fun to be out on the slopes. But we appreciate you coming in and kind of acting as our Sherlock. I will play Watson, I guess, today as you help
Exactly.
figure out how to navigate our way through. Does that make like Rigo Moriarty? Like, is he the one that like caused all our
Oh,
problems?
the big bad guy. No, I think it should be James who hides behind all of the tech that makes this happen for us, right? He's pulling the strings and making sure we look and sound as good as we do over these episodes. So thanks to James for that.
Oh no, absolutely, absolutely. So we've got quite the audience coming in from today.
I
I'm
see
sure
that.
you appreciate the representation from Canada,
Yeah,
right? Strong showing for CCNA prep here on this area
yeah.
this session.
I mean, look, the spread is amazing from Europe, from Africa, from Asia. Fantastic representation from all over the place. Obviously, some Canada, but I love the big message there. I love networking, and I train the stimulator to others. I'm not quite sure what that means, but I like the intent with that message for sure.
It's a state of mind, I think, is
It's
where they're coming
exactly.
from, right? Just loving that's in there. So no, it's really has been fantastic this season, last season, and Rigo, you're in the community all the time, and just knowing how wide and varied and where everybody comes from. It's one of my favorite parts, right? Just knowing that, hey, I'm sitting here in my basement in Ohio, and we're out there kind of collaborating, talking with, kind of hearing questions from folks from all over the world, and the excitement for CCNA, the excitement for networking. So keep coming, right? Keep coming back. Keep being part of this community. It's really, really is quite fantastic.
And I'm going to use a $10 word here. It's the penultimate episode of season 2. So the last one in a couple of weeks will be on SNMP, Simple Network Management Protocol, which will be an interesting one. Again, we'll use CML to demo that. But today is all about Syslog. And I mean, just again, for some context, I know we always talk about the exam, but just let maybe start with that one actually. So this is the exam topic, right, Hank, that references Syslog. And so it's it's not too scary. It's a describe topic, right? It's not a configure and verify, although that's what we're going to be doing a lot of today on the call. On the live stream, we're going to be looking at how to verify, how to check how the configuration is set up, and then actually modify some of that configuration. But then it talks about these two things, right, within Syslog. Facilities and levels. We're going to talk about those two today for sure before we finish the episode. Before we get started though, Hank, we were just talking about all this interesting terminology around Syslog before we jumped on the live stream, and I just wanted to kind of set the scene a little bit for folks. I'm going to be using three kind of different terms. They all kind of go together and work hand in hand, but I just want to make sure everyone's clear. So the three terms I'm going to be using a lot of are logs or log messages. So those are pretty straightforward. Those are just the messages that appear in front of you when you're at the console. Then there's also logging, which is how you configure all of these messages. How do you want them to appear and where they should go? So logging is what we're going to verify on the router in terms of how it's configured. And then finally Syslog, right, which is that protocol that we can use to send these messages to an external server. Is there any other that jumps out at you for sys, for terminology that we should mention?
Yeah, I mean, you've hit the big ones that are there, and this is one of those areas we sometimes hit with networking where the same words start to vary depending on context. You mentioned it as you went through, but I would specifically call out log server, right? Because that is another big part of the Syslog architecture, right? So we have a device that is doing something and generating log messages, and it's going to go ahead and use Syslog protocol to send those log messages to a log server as they go in. And then that's kind of the basic architecture. And hopefully for everybody that's kind of been joining us and been here with us through the season, this isn't the first one of our blueprint items that doesn't focus on configuration or verification on the CCNA blueprint. But I don't know. And Patrick and I have talked about this before, and hopefully everybody out there in the chat is agreeing with us that you really can understand stuff much better if you have done some implementation, if you've learned how it works, if you've kind of peeked behind the curtain of the packet capture and kind of seen things moving. It really helps kind of deepen your understanding of these topics so that you can do a better job when you're asked to describe it on the exam. So
I'm glad you mentioned the packet capture. I was just doing a little demo for some other learners last week about 802.1q, and we just grabbed a quick packet capture in CML just to look at that tag right on the trunk. The native VLAN, it's untagged. So that packet capture, you can use it for all kinds of stuff, right? OSPF packets and CDP stuff. So it's such a nice way to actually see it in practice, right? We learn about all these things, and then it's great to be able to see them actually in action too. So that's good.
Yeah, it's really a fantastic feature that's in place that we've got here in CML, and we've got similar ones in Packet Tracer as well that I've taken advantage of with activities on that side. All right, so go ahead, Patrick.
No, the last thing I want to just have a quick chat about is the elephant in the room when it comes to Syslog, and it's this right here, and I've put them on the in CML itself, right? So if you download the YAML file, you'll have this. This is so important. And this is probably where people have the most, honestly, the most difficulty, because configuring Syslog isn't hard. It's a couple of commands. It's pretty straightforward. But typically the questions you're going to get around your CCNA, or even if you're doing NetAcad, right? You've got these different tests and chapter exams that you'll do in NetAcad will be around learning the different levels of Syslog severity. So maybe we can just talk a little bit about this. And I think the challenge for folks is the same challenge I had when I learned the OSI model a long time ago. I was just trying to remember what the order of those layers for the OSI model was, and coming up with the mnemonic. I don't know if you had one, Hank, but mine was the classic, please do not throw sausage pizza away. So definitely not for vegetarians, but it was the way that I remembered the OSI model. And so I Googled quickly a couple of days ago useful mnemonics that people are using for severity levels, and this is the one I came up with. Every awesome Cisco engineer will need ice cream daily. I like that. I think ice cream. Yeah, I'd be happy with some ice cream every day, I think.
Yeah. It's certainly a positive one, and you hit it hard, right? There's a certain aspect when you get started in any industry. It's not just networking, but certainly something in networking, that there's just a certain amount of jargon and dialogue and terminology and definitions you need to know. Yeah. And eventually you internalize those things. But at the start, it really just comes down to rote memorization, right? Nobody likes to be told, well, you just have to memorize this because we said so. But frankly, there's a few things you just have to memorize. The OSI layers, all the details here with Syslog to keep it constant in this area. And then this is another one of those. We've talked about this. I think we talked about it in season 1. I know it's come up in season 2 a few times. We've got numbers that go with these as well, right? 0, 1, 2, up to 7.
Yeah.
And so I know that I've been hung up a few times. Like I had a question on an exam or multiple choice someplace, and it's like, okay, what's worse, a level 0 or a level 7?
Exactly.
And so that's another
Spot
area
on.
of kind of memorizing. Okay, in Syslog, the lower the number, the worse it is. Right?
Exactly.
Some of those little things, just kind of honing in on those and kind of remembering that piece will help you dramatically as you go through. So.
And I think we were just talking also about how maybe we can give folks a CCNA exam tip of the day here, which is before you start your exam, you're going to get a dry erase marker and a little dry erase pad, and you can actually write down a bunch of stuff to help you kind of during the exam. So before you actually start the exam, you can sit down and write down a bunch of things. And I think the idea here is you could jot down the OSI model, for example. You could definitely jot down the severity levels for Syslog, so that you can quickly reference them during the exam. And I think, Hank, you mentioned another, it's a classic one, that subnetting information, right? Your subnet calculator or anything like that. So apologies for all these pop-ups I'm getting. I keep shutting down my WebEx, but I don't know if you guys are seeing, oh, maybe it's over here. I can kill, there we go. Now that's going to stop. Apologies for that. Anyways, yeah, so just that tip of the day, I think, Hank, I remember doing that, honestly, like when I went for my CCNA, just jotting down a bunch of stuff on this before starting the exam. I don't know if you did too, but.
No, absolutely. And it's not just the CCNA exam. Every exam, maybe not every exam, but lots of the exams I've gone through. I remember when I sat down for some of the CCNP exams back in the day, is like writing down the BGP algorithm, like what's the order for those,
classic.
just to get it on the paper. It's just, again, some of those things you just have to memorize until they're internalized. Don't be shy, right? I'm not a fan of cramming right before you go into an exam, but there'll be a few things you'll look at before you go in, and then just kind of spew them out
just
onto the piece of dry erase, and then you've got them available as you go through the rest of the session.
So as Hank said, this is a really important piece of information, these severity levels. And I think that the last thing I'll say before we jump into the demo is, when we set a severity level, it includes everything below that, right? So if I set a severity level of, let's say 2 on something, right? We're going to get to that in a second about the configuration. But if I set a level 2, that means that the messages that will be gathered and displayed are up to 2. So that includes 0, 1, and 2. And so just a little heads up about that's also a really, really critical piece of information when it comes to using this table here. Cool. All right. Anything else, Hank, before we jump in, or are we ready to go?
No, I think we're ready to dive in. I know that out in the chat, if you're there, kind of dive in. If you've learned a specific mnemonic to help you memorize the severity levels and want to share it with everybody, drop it in chat. We'd love to see what some of those examples are. But Patrick, let's dive into it. Let's take a look at some logging.
So I'm going to break down this lab in 3 parts. Part 1, we're just going to quickly review the default logging settings on a router, right? So I'm going to do a couple of show run commands, and we'll have a look at the timestamps, and we'll have a look at the clock also. Hank, you ran the NTP session last time. We talked about how critical NTP was, about synchronizing the clock. What's your take on how important the clock and the time on Cisco devices, or any devices, for logging purposes? Is that important or not?
Oh God, it's so important. And I would say that it's the properly timestamping your log messages is like the first thing most network engineers run into where time really matters, right? Because a lot of the stuff we do in the network, the switch is going to work whether it thinks it's the year 1993 or whether it thinks it's the year 2025. It's still going to switch packets and go through that. But when you go to look at a log message and see if you show up and you realize your router had rebooted and there was an outage and you're trying to go back through log messages and things aren't lining up, right? That is such a critical aspect. And so again, having that time appropriate is really important.
So what I did for this lab today, Hank, is I reused the same topology you created for the NTP session from a couple of weeks ago, because I knew, right, the clock is important. But what we do know, if you guys tuned in a couple of weeks ago, you know that NTP isn't the fastest protocol in the world. And you can see I just did a show clock, and unfortunately, my clock isn't synchronized at all, right? I'm looking at 1993 here. And if I pull up, for example, I don't know, let's show NTP status. Oops, sorry, NTP status.
I think part of the reason not syncing is just how different it is. I mean, look at that offset value.
I
right?
know it's going to take forever. Yeah,
Yeah.
exactly. So I am trying, right? You can see that it's Stratum 2, so it is pointing to that 192.168.100 NTP server that Hank spun up a couple of weeks ago, but it's just not setting the clock because that I'm currently configured for 1993. So let's just quickly set the clock. If you guys remember what the command was, clock set. I'm going to do, okay, so it's 11:15 here. So what is that UTC? So plus 7.
I'd say depending on where you're at. I know I'm looking at mine, and
let's go 18:15. Let's say 00, and then today is the 17th of April. And 2025. Let's just go with that as my clock, right? So I've set the time. And I think this is a great moment to just have a look at this message here, because we saw this message a couple of weeks ago when we set the time. And here is, ladies and gentlemen, your first log message, right? So let's maybe break it down together a little bit, Hank. So I'm going to put you on the spot. Obviously, we've got the time here, and I'm going to come back to the time stamping in just a second, but I thought we'd jump right into this. This sys thing here, what do you remember what that's all about?
Yeah, so there obviously, even though we think of a switch, or in this case, a router, as one thing, right? There are, on that router, right? The router is really just a computer, and it has a lot of different processes and applications and things that are running. There's the ART process. If it's running a routing protocol, that would be a process. And then there's the underlying system, just kind of the foundation pieces. And so that first portion is just pointing to which part of the router system, which application or service on the router generated this message. So in this case, it's kind of like the system, the raw system of itself. Yeah.
And we'll come back to this also towards the end of the session. It refers to something called the facility. So as Hank was saying, it's like the component in the router that's just generated that message. And Cisco iOS uses a bit of a different naming structure to that facility than the actual Syslog RFC. Let's just kind of put that aside for a moment, and we'll get back to it in a little bit. Hank, what's this number 6 all about?
Oh, well, that's back to where we started, right? That's the level of syslog message that's in place. So it's a 6, which tells us it's the ice cream message, right?
Yeah, exactly. It is the ice cream message. So it's just a bit of information, right? It's not critical. It's not an emergency. It's just letting you know, hey, something's happened, and it's informing us. And what is that something? And I really like what comes right after the severity level, Hank, right? It's usually a very clear little bit of messaging to help us kind of understand what that's all about. And this one, I mean, it reads really easily. It's just we've updated the clock, and then we get the actual log message itself, right? So that's looking good. I'm going to do something that not many people do usually on a Cisco route. I'm going to use a bit of a scary command here. I don't know if you guys are familiar in chat. If you've ever seen this command before, maybe in chat, let us know. The show run all command. This is a bit scary because it's going to generate, I don't know, dozens and dozens of pages of configuration. But obviously, I don't want to look at all of them. What I'd like to do is just have a look at the commands in the running config, which refer to logging in particular, right? Because we talked about how this is a log message, but now I want to have a look at the logging config on the router itself. And we're going to see, actually, there's quite a few here. I'm just going to kind of scroll through and come back up and pull up a few. Yeah,
before we dive into like the logging command messages that are here, for folks that may not be familiar with the show run all command, what is it doing that's different than just show run? Why is there so much more configuration versus what we get with just a show run?
It's the show run all, from what I gather, it gives us all of the default config that's kind of hidden from the regular show run, right? So there's a bunch of extra commands here that we're going to see, which they're on by default, right? When you boot up the router, they've been enabled, or as you can see, there's a bunch of them that say no something. And that's just the default value, right? So we don't see it in the typical running config. Is that your take on that as well?
Exactly. Yeah, there are a lot of just default settings that are established by I would say Cisco, but the software development team, the product management team that set this up. And these are the settings that are just expected, but have to be there. And the show run all, it's available on a handful of different platforms that are there, but it can be a handy way just to kind of look at it and peek and see all the things that are happening that maybe you didn't think of, right? So things we see in here in the output, there was a count message, I think, up above, and we can see rate limit console. Like there's all these settings that sometimes can make you think of things that are, oh, I didn't know I could manipulate that. That's an interesting thing. So if you've got some time and go through, definitely experiment with show run all and just kind of skim through it and see what are some of the ones. particularly like at the interface configuration level. I'm often kind of surprised by how many things are on by our default configuration settings that we don't actually see. So.
Yeah, no, that's a really good point, because we do a regular show run and we see maybe 3 or 4 lines of config on an interface. You do the show run all interface, E00, and you get a massive paragraph of stuff as well. So, so let me just pull out the kind of interesting stuff that we'll focus on in the Syslog episode. So there's this one here, and again, there's a bit of funny terminology here, and we'll kind of go over it as we go through the episode. So this one talks about how the buffer, right? So the RAM buffer of logging messages is set to a certain size, 4096 bytes, and it's set for the debugging level, which means that from 0 to 7, any message generated will be saved to the RAM, which we call here the logging buffer, up to a certain amount. And then if it gets full, obviously older messages get deleted and new ones come into play. We'll see later how we can kind of manipulate that a little bit. This is an interesting one here, right, Hank? Logging is on, and the proof was that a few minutes ago when we changed the clock, we got a log message, right? We got a log message at the console. So logging is on, right? We're receiving, so it's, I guess what we're basically seeing here is that we can turn that off. We could say a no logging on, which I know sounds really weird. I know, right? And that would just stop all logging going anywhere, right? So the console, everything would be very, very quiet. You wouldn't get any messages at all. So
also not a recommended setting, right? Generally, you want those log messages. If you turn it off, you won't get the console messages. You won't get the logging buffer. You won't get, you won't know when things go wrong. So so outside of a lab, I definitely wouldn't recommend turning logging off with no logging on. So,
and these two here, these are default settings again on our router. So the console is set to debugging, which means it'll get all messages from 0 to 7, and the monitor, which I know sounds a bit weird. This is actually terminal monitor that it's talking about. It's telnet sessions, SSH sessions. So anyone who's connected remotely to on my router here would get messages. We'll see, we have to turn on another little command to actually make that happen. But basically what it's saying is that it will send pretty much anything from 0 to level 7 to those terminal sessions. So that's another interesting one. Let me just scroll down. There's a couple more here I just want to point out. This one, we're definitely going to get to it towards the end of the session. So what the heck's a trap? I know it sounds weird, Hank. What when you see trap, what are you thinking? How do you define that in your head in terms of?
Yeah, I mean, for me, the connection to logging trap doesn't start with logging. It comes back to just my understanding of SNMP, which is something we're going to talk about next week.
Yeah,
is that a trap is just a message in SNMP. It's a message that gets sent out, right? Yeah. So the idea here is that we've trapped something. There's some event that happened, and we're going to kind of take an action. In this case, we're going to send it someplace. So this is when we're going to send things off to that logging server that we discussed. By default, right? Unless you tell the router where to send messages to, it doesn't know, so it's not sending them. But the idea here is that says, okay, if I was to send a message, right, what level am I going to send? Which is different than what we've seen in all of the other examples.
Yeah, it's only set up to level 6, so from 0 to 6 would be sent to this fictitious location. We haven't configured anything yet, but it's kind of ready. It's basically saying if I do start sending some stuff, I'm not going to include debugging messages to that external server, for example. Right. I mean, the last one, and again, we'll come back to it more towards the end of the session, is this. Hank kind of talked a little bit about it earlier, and I kind of mentioned as well. Remember earlier when we saw that clock message, it had sys, and we were talking about different parts of the router generating these different types of messages. We call that a facility. And there's 2 different ways of looking at the concept of facility. The Cisco way, which is like using actually words that make sense in terms of what part of the router generated that message. And then if ever you're into reading RFCs in your spare time, you can pull up the Syslog RFC and see that actually the definition of the facility it uses different words. And so local 7 is just a locally defined value that it uses for that particular style of messages for the RFC, and we'll see it actually later on when we do the packet capture. This is going to come up again. Yep. One last little thing I'm going to do here. I'm going to have a look at those timestamps because I do have a Slido question. Maybe should we pull up the answer? I'm going to.
It's active now. Yeah. Do you want to show it off?
Rigo, let's have a look at the answers before we get into here, and then kind of tell folks what we think the answer is. So what kind of responses did we get so far on this one?
Yeah, absolutely. So we asked our audience which 2 commands allow for the most precise UTC timestamping on log and debug messages on a Cisco router. And it looks like our participants did pretty good here. So we got service timestamps log datetime MSEC and service timestamp debug datetime MSEC as our two top answers out of the group. Yep. What do you guys think?
Yeah, no, that makes sense. And I wasn't trying to come up with a too challenging question to start it off here this afternoon or this morning, wherever you are. Obviously, the millisecond value is the thing that I was really looking for, right? We want to get down to the milliseconds because that's, Hank, you've seen this before. Sometimes you start getting a bunch of messages and you really want to see which message came before which, and it has to go down to the millisecond because some of these are happening pretty quickly in the router, right?
Yeah. Yeah, and I would say that's generally the more common one. I think we're going to see it as we go through the lab and we do some of these configuration pieces. But there are other options, right? That I think there's a way to say, well, just show me what order the messages came in. I don't care when, just show me what order they were.
Exactly.
That's not terribly useful in my opinion. Like I want to see the times, right? When did it happen? Because I know that there was a help desk ticket that came in last night at 3 a.m. Right? I want to figure out what was going on around that time as it went through. So.
And then the point I was trying to make with this first question I came up with was the idea that, as you can see by the config that I've pulled up, you can actually set the command to show the local time of the router. And again, it would come down to the same conversation we had a couple of weeks ago when we looked at NTP. Should you set all your devices to UTC or should you set your devices to local time? I think, Hank, you had a strong opinion about which one strong opinion. You had an opinion about which one did you prefer at the end of the day?
Yeah. I generally prefer UTC because it keeps it consistent. I don't have to know that this router was on the East Coast, that router's on the West Coast. Time zones are different, and add math on that side. But let's let Rigo advance our question to the next one, and then we can jump back and actually show these configurations off. And then we actually had a question that came in from chat, which I think is fantastic.
Sure.
So when you did the show run all, one of the logging messages that came through that it looks like Kenny spotted was logging persistent. And the question was like, what does that mean? Right? Where does logging persistent fit in? Yeah, there you go. No logging persistent. So we're not doing it, whatever it is. What would it be if we were doing it?
I've never turned that one on actually. So I'm gonna kind of have a think and look it up maybe later and come back to it. Unless have you played with this one before?
Yeah, I've got some experience with this one. So the idea is the logging buffer, Patrick, as you mentioned it, like that's what's in RAM when the router is up and running as it goes through. Well, what happens when a router crashes or reboots? Well, everything that's in RAM goes away, right? It's not persistent and it's lost. Sometimes that's okay, but if you've got a problem where a router's rebooting and crashing and you're losing all the log messages about what happened just before it crashed, well, that can be difficult and a challenge. And so with persistent logging, you can actually set it up so that the router kind of writes those to a local file so that it can be persistent across reboots, and you can give it a size and all the rest of those details that are in there. So it's for me, it's interesting that it's off by default because it's a really useful feature, particularly if you don't have a remote syslog host where you're sending the messages to. If you don't have that, kind of enabling persistent logging can be super useful because there's nothing worse than kind of showing up and trying to debug an issue and then realizing, well, you don't have any data because it was all flushed when the router crashed over the night.
The last little command I want to have a look at before we actually jump into the logging configuration is this one. I'm not going to turn it on, but I just want to point it out because Hank made a comment earlier about, I don't really care about what time the message maybe appeared. I just want to have, what order they appeared in. And so what you can do is you can disable the timestamp and go with sequence numbers instead. So if you want to play with this, have a go, spin up your CML, open this lab, generate some messages, change it to the sequence numbers, and you'll literally see it's a sequence number like 1, 2, 3, 4, right? And as the messages come in, that number increases. So it's just a different way of displaying those log messages that are appearing at the console or in the telnet or SSH sessions. Have you used this one as well, Hank, in the past, or not so often?
I have. I usually stick with kind of just the timestamps that are in place, but I've seen the sequence numbers and used for sure.
All right. We're ready to start investigating actual logging configurations. Like I said, I want to have a look initially at the console and those terminal session loggings, and then we'll have a look after that at the buffer and the syslog itself. So I'm going to just open up my window a little bit bigger because I'm going to do the show logging command, which is probably the most useful one to just kind of have a quick breakdown of how logging is currently configured. So remember, log messages, logging is the configuration, if you like, and then syslog will be that protocol we're going to use to send messages to our external router. And as you can see, holy smokes, a lot of stuff is appearing here, right? A lot of messages. So let me just come back up at the top. So first things first, we know that, In fact, logging is enabled. We saw it a few minutes ago, right? Logging on, so that's good. We talked about console logging. You can see that that's set up to level debugging. A bunch of messages have already been sent. We can see that monitor is also set to debug. We know all this, right? We just had a look at the default config and the show run. We know that the buffer is also set to debugging. And you can see it says 41 messages were sent. And I kind of scrolled through them just a minute ago, right? If I go back down, right, all of these messages, that's in RAM. So if I turn off the router, turn back on, right, we lose all of this. And this is what you were saying earlier about that persistent stuff. We could generate these and send them to maybe the flash or something like that. Obviously, we can also send them to the Syslog server too. So this is, again, I just wanted to kind of point out what kind of highlights it. And again, there's a bunch of other things we're going to get to a bit later on, like the trap login we talked about a little bit earlier, the size of the buffer. Here's that persistent login that's been disabled as well. So again, we're just pointing out a few things, because a classic CCNA exam would be exam question would be to show you the output, right, from this command and ask you something about it, something challenging maybe, right, to interpret, right, and be able to describe what you're looking at here. So what I'd like to do to start off with is just change, maybe I want to keep maybe this to the level debugging, but what I want to do is I want to change this one here to a lower level than debugging, just to show you something quite interesting. What I'm going to do is I'm going to change this. Then I'm going to go to the PC that's on the left side here of our topology, and I'm going to telnet into the router. And what that means is I'll have a telnet session into the router, and we'll have our console session. And then I'll do something like shut an interface on the router. And I just want to show you the different levels of messages that appear and where they appear at that point. So let's have a look at that. So we're going to do logging. I'm going to do monitor. And I'm going to set it to level 3. So again, just a reminder, 3 includes 3, 2, 1, and 0, right? Everything below that. And you can see this lovely message we already got at the console indicating at level 5, log config change has been set to the errors level. So here we go. I'm going to go back to my PC here, and we're going to telnet to, I think I can use this, right, Hank? I can use the DNS, maybe look up to connect.
You should be able to.
Hey, look at that. And I think it's telnet pass. Fantastic. So there we go, folks. And I'm going to go into enable pass. Fantastic. So here we go. We've got our telnet session into the router, and we've got, obviously, our console is already connected to the router. Now, before I do anything, I mentioned a little something earlier, and this is a tricky one. So I have set the monitor up to level 3. What that basically means is that the router is ready to send those messages and will send those messages to a telnet session, which I have now. But I do need to turn on a little special command to actually show these at my telnet session. Hank, I'm going to put you on the spot. Maybe you haven't done this command in a while. We'll see how your CCIE knowledge is. Do you remember what that command is? It's 2 words.
It is. It's just 2 words, and it's one I've used many times to go through. Most of my
trying to catch you out there, but
devices
go ahead.
is through telnet or SSH, and this is the terminal monitor, right? Which ties back to that logging monitor that we saw in the configuration and the output that's there. We're basically saying, hey, in this telnet session, I want to look at that monitor. I want to pay attention to those messages as they come through.
So now all I want to do, folks, is do something to generate some cool messages. And what I came up with was just basically do a shut, no shut on the E00 interface on the router. And that's the interface, as you can see in the topology, that's connected to that cloud. That should generate, I'm expecting 5 messages. 2 when it goes down, 2 when it comes back up, and the 5th one should be a DHCP message when, I need to maybe spell that properly, there we go, when it gets its address again. Because if you remember, we're using that external connector in CML, and DHCP is running there, and so I should get some messages on that. Okay, interesting, I thought it was, oh yes, oh that's true.
Yeah.
Don't forget, I set it to level 3. Yeah, I was waiting for something. I would be waiting for a long time. Hey, fantastic. There it is. So I said there'd be 5 messages. I will show them to you in just a second. I'll go back to the console. But strangely enough, I only got 1 message. And why did I only get 1 message? Obviously, it's because I set it to level 3. And as you can see, we've got a link message up, down, and that's a level 3 message telling me that the interface has come back up. Which means that all the other messages that when the interface came down and that DHCP message should be higher than level 3, right? I know it's annoying to say kind of lower and higher because one is worse, one is better, but hopefully folks are understanding what I'm getting at. So here we go. I've come back to the console, and here are those 5 messages that I promised. So the first 2 when the interface went down, and again, you can see they're level 5. And then the next 2 when the interface came back up, and again, you can see that level 3 and the level 5. And then there we go, as promised, that DHCP message as well, which is a level 6. So again, not really complicated, folks here. All I want to show you is that it is possible to kind of limit the types and levels of messages that are sent to different places.
I think another thing to point out here is it always, and when I was going through this lab, Patrick, as you went through it, it kind of caught me off guard because to me, it seems unintuitive that the interface going down is considered not as important or not as severe as the interface coming back up. And so the reason I point that out is it's as you're going through and understanding what these messages are, kind of paying attention to what those levels are, because it may not be what you automatically assume. And that is not something that you can necessarily change. Like you can't change the level of severity of an interface down message to be an error, right? Those are kind of baked in by the software vendor. Every network device or every network application or honestly, it's not just networks, right? Web servers, domain control, like all these things can send out syslog messages. So kind of the assignment of what the level or severity of an action and an activity are is all done and owned by the software vendors. So.
Yeah. But you're right. It's very strange that it'd be just what was that, level 5? If we have a look at our severity level, right? Level 5 is a notification. So you've just been notified, not in any not a panic. I'm just letting you know that this interface has gone down. And good luck with that. Folks, I just did that show logging command again. And I just want to point out, right, the changes that we made. So we changed the levels to the monitor logging. And there you go. That's that one message that we saw, that level 3 message that appeared. And obviously, if I scroll all the way to the bottom of all these messages, we do also see all the 5 messages that we were talking about earlier, as well as the interface went down and came across and came back up in the DHCP. We should maybe have a look at the next Slido question. How's that looking? Rigo, can we have a look at that, please?
Absolutely, yeah. So what are the 4 most common destinations for log messages? And this one had a handful of options to choose from, but it's also got a good mix of answers from our attendees. And we got the 4 top answers here from top to bottom. We got syslog server, console, we got terminal monitoring, and RAM buffer.
Nice.
Yeah, I think they did pretty well here too. What do you guys think?
Yeah, no, I'm happy with that. Hank, you were talking about that persistent stuff, right? And I mentioned we could save it to flash, but maybe that's not the question of popular, but most common destination, because it's right. But yeah,
I think your answer choices here are valid, right? And obviously this isn't an actual exam, so the level of kind of Q&A check we do on these isn't quite the same as what you're going to get from the Pearson test you go through. But I still think it's fair because logging to NVRAM, which would be your flash, right? That is not the most common use case. It's turned off by default. Like you have to go into it. These other ones are far more common. So I think that, and I give the audience like a ton of credit here, our chat, ton of credit. They know their stuff. They kind of hit those ones that are key. I mean, the default of console, RAM buffer, and terminal monitoring, like those are turned on by default. So they're definitely the most common. So then if I had to pick, well, is it syslog server, NVRAM, TFTP, or USB? Right, the one that I'm going to jump to there is syslog server, and I would hope the audience would too, as they're thinking through that question on their own.
Yeah, no, I agree. And again, coming back to that CCNA exam, you could have a similar question or one that's pointing to that show logging output and asking you, what type of message is being sent to which destination, right? And again, that comes back to making sure you know your severity levels and being able to interpret what the output is from this command. And obviously, speaking of which, let's set up that next question then for us, Rigo. We're going to have a look at the 2 other areas that we can send those messages to as promised. So the buffer, we've all kind of looked at it a little bit, but I'm just going to show you what the command looks like to modify that buffer in terms of the size and the level of debugging. And then we'll get to the syslog, where we're actually going to send those traps. Right? We're trapping information and then sending it to the syslog server. So have a look at this default information. Again, we kind of pointed it out earlier. The buffer login is set to debugging, which is the whole shebang, right, from 0 to 7. A bunch of messages have been sent already, and we know where this buffer is. This buffer is right now, right here on the router. It's in the RAM, and this is that massive list of log messages that I keep scrolling up and down through that are being generated. So the point I'm trying to make is that this buffer right now is limited, right? 4,096 bytes. So I'll show you how we can modify the size of that in case you wanted to, and how to modify the level of debugging being sent there. Maybe you don't want debugging, right? And then we'll get to the trap logging as well. So let's have a look at that then. So I'm going to use the login buffer. I'm going to look at this here. So you can see that one of the options is the size. So I'll do that first. Actually, I'll do, let's say 8192. I'm just going to double the size of the RAM buffer. And then if I do a question mark again, you can see that it then asks me, okay, what level of severity do you want to do here? And again, I'm just going to change it to something just so that it's different from debugging, because everything was set up as debugging by default. Let's just change it to, let's say level 4. Again, if we have a look at our syslog severity levels, that means it's called warnings. I could have used the warnings word instead, which I can if you'd like as well. There you go, warnings. So I can use the number or the message itself. So I'm just gonna wait for a second. So here we go. First things first, we get a log message. We can see that it's been produced by the system facility. It's a level 5 message. Something's changed. It's the buffer login that's changed. It's been changed to warnings. And oh, by the way, the size has been changed as well. So nothing too crazy here. But what I do want to show you that I didn't even know until I started playing with this. If I do a show logging, so obviously it's telling me that the warnings is now the new level, which is, I'm happy with that, obviously. Have a look at this though. And then if I scroll down a little bit, we've got our buffer, and the buffer has been wiped. So just a little warning, if you do start playing with the buffer size, don't panic. As soon as you change the level or the size, it clears out that RAM buffer, gives you a clean buffer here in this case. So just a little warning about that. I don't know, Hank, if you ever come across this, but I hadn't realized that when you change the level or the size of the buffer, you get a clean buffer.
I think I probably knew that at one point, but when I ran through the lab, I was a little surprised as it went in. So I think that's a key aspect of understanding kind of the impact of logs, making sure you capture them. If you only have them on device in the local log buffer, that you're capturing those ones before you do anything that might reset them. Because there's a manual statement as well, like clear, I think it's clear logs or clear logging.
Yes.
Will wipe that out as well. So just make sure you capture anything before you kind of, and it's gone.
Yeah. And I just turned it off and turned that interface off and on again, just to kind of generate some messages at the buffer, at the console. And so if I go back to my show logging, I should have, right, you can see 2 messages were logged. And maybe I just cut that off a little bit. There we go. So I've got this message here. The previous message would have been, apologies, I looked at the wrong thing here. There we go. One message was logged to the buffer because it was set to warnings. If you remember, warnings is level 4. So all the level 5 messages aren't being sent to the buffer right now. So it'd be 4 and below, which comes back to that level 3 message that we saw earlier when I brought the interface back up as well. And again, we've got our buffer size too. That's up to 8192. Maybe we'll have a look at the Slido before we jump into the syslog. Rigo, what's that looking like?
Yeah, so for this latest poll, we asked what levels will be trapped if the administrator executes the command shown in the exhibit. And honestly, our audience did an excellent job with this one. So we got alert, emergency, critical, and error as the answers here. I'll let you guys speak to the answers a bit more.
Yeah, I was just reviewing what we've been talking about for the last 43 minutes and just making sure folks understand that when we set a certain level, it includes everything below that. So as you can see by my cute screenshot that I took from CML, I set the logging trap to level 3, which is what we did earlier. And so I was expecting 3, 2, 1, and 0. So errors, criticals, alerts, and emergencies. Did I put oh yeah, I did put emergencies there.
Yeah. And this type of question I think is important because it kind of forces or allows us to test the candidate on a few different layers, right? Do you understand kind of how it works, that you're going to get the more severe aspects? Also, do you know what order they go in, right? Do you know what is more severe that's in place? Yeah. And then do you know what level 3 is? So there's a lot. This one question allows us to kind of verify the knowledge of the candidate in a lot of different areas. So this is really a great example of the type of question you might see in the exam. And we also had a question that came in from Chad, and I've been trying to keep up with most of the questions as they came through. That kind of hits directly on this. And in chat, I said, well, the idea was we were given the wrong information because if you set up for level 3, you receive the upper levels, not 3, 2, 1, and 0. And this kind of comes back to that. upper, right? It's hard to use
Yeah.
that word. I always try to use the word more severe, less severe of a message. And so
Yeah.
in Syslog, the more severe messages, like the levels are actually lower numbers.
Yeah.
Right? So that's the key aspect that goes in here. So the idea is, yes, if you set it at level 3, you're going to get level 3 and worse or more important messages. But those happen to be lower numbers, right? It can kind of wrap your brain a little weird.
It can. And again, coming back to that tip of the day we said at the beginning of the
Mhm.
session, if you're sitting your exam and you quickly write down a bunch of stuff on that dry erase pad, if you've got those written down, how easy is that question then to answer, right? When you've got that right in front of you, you don't have to get worried too much about, did I get them all right? You've got them right there on that pad for you. So definitely think about doing that when you're taking the exam.
Mm-hmm. Mm-hmm.
Okay, folks, we're almost at the end here. We've got one last thing to do, which is having a look at actually Syslog itself. So we talked about this trap logging, and we talked about what, and again, I think of a trap, right? It's trapping, it's grabbing, it's capturing messages, and it wants to send them somewhere. It's not sending them anywhere right now, so we need to fix that. And it's going to send up to level informational, right? We talked about that, which means 0, 1, 2, 3, 4, 5, 6, right? That are going to be sent somewhere, but we need to set that up. So here we go. Logging, right? We'll do a question mark. You can see there's a bunch of subcommands with the logging command, right? The one I want though is logging host. So I want to specify the IP address of the server where I want to send all these messages. And I'll just pretend that Hank's NTP server is also a syslog server, and that's where I want to send them. So as simple as that. I'm going to wait a second or two. Here we go. Nice little console message here, a log message. Again, produced by the system. It's a level 6 message. And it looks like we've started or maybe stopped, right? If I had done a no, it would have been a stop. But here we started the logging to that server. So I love how it's written here. It's really clear. And we're logging to the host at the address I specified to port 514.
Yeah,
go ahead, Hank. Yeah.
I want to jump in on that one a little bit. So they kind of,
sure.
We know it's on port 514. So the question, I guess, for the chat at this point, kind of send them our way as it comes in, is what protocol is it, right? So it's port 514 that's in there. This is another question that may come in, right? There's a few of these things we expect. So what protocol port 514? So we're going to give it a second to let folks kind of answer and provide us some Q&A, answer those questions as they go through. But this is something that's important to understand. And then
actually,
we'll talk a little.
I have a secret for you.
Oh.
If you have a look at the Slido poll, the next question is asking something about that.
Oh,
maybe we can jump right into that question then, instead of waiting, because we don't want to give away the answer. So I think, Rigo, that next question is up. I can see 28 people have answered, I think, so far. Basically, it's asking a couple of questions around the syslog config, and one of them is I think what you're getting at, Hank. What is it? TCP? Is it UDP? So,
I like it.
should we let people think about that a little bit and not give out the answer and come back to it a little bit later or something?
We'll give it for a second. Well, let's talk about some of the potential impacts as we go here, right? So we've got some messages that are in there. Obviously, it's probably TCP or UDP based on your questions that are in here. What would be the impact if it's TCP versus UDP? So if it's a UDP based one, what does that mean? Right. So Patrick, if we're sending across UDP, what's the impact of that on these messages?
It's what we call connectionless, right? There's no TCP three-way handshake. It's less overhead. So all of these kind of real-time protocols use typically UDP just to minimize the impact of resources being used to keep track of TCP sessions that are open. So here it's just UDP. If folks are familiar with TFTP, for example, which is something we talk about in CCNA, you want to do a backup of a iOS or backup of a config, you use TFTP. It just dumps it, right? There's no warning. It's like, here you go. Here's a message. Here's another message. It just throws it at that destination.
And DNS is another UDP one, but logging is an important application, right? Making sure that the logs are there. If Syslog uses UDP, that means that there's no verification that the logs are delivered. I don't know if I like that, right? I might want to know the messages go through. So there's aspects and impacts to whether an application is what the protocols are. So with all those in place, I think we've probably given folks enough. We've got 56 folks in. So what is the answer?
Yeah, Rigo, what's the story?
All right, so we got top answer. We got Syslog is a protocol that allows a network device to send event notification messages. And then we also got Syslog sends messages via UDP on port 514.
Nice. Yeah, no, definitely. I think they're on the right track here, Hank. And I'll be honest, and I just want to point something out, that when I did that command, I don't know if I can do it here and show folks. Yeah, check this out.
Hold
we
on,
go.
people aren't seeing your screen yet there, Patrick.
Okay. All right, let's wait.
They're seeing it now.
Oh, thanks.
Yeah.
I guess I should have also said regarding default syslog, right?
Mhm.
Because in fact, it is possible to, as Hank is getting at, change it to TCP if you wanted to. So for example, if the server was across a WAN and you really wanted to make sure those messages are getting across the WAN from a branch location to your data center, maybe you do want to set up TCP. Maybe you're also going to set it to up to level 3 or 4, right? You don't want to start dumping loads and loads of messages across the TCP session to that server. But again, maybe my question, I should have been a little bit more specific, but I'm glad folks honed in on the UDP as the config.
And that is the most common deployment that's in there. But I think that's kind of the reason I kind of brought that up is that's an important aspect when you're designing networks, or maybe it's not you as the CCNA candidate, but as your senior network engineers are kind of designing these are some of the decisions that have to be made. Like, how important is it to make sure that those messages are delivered and resending if there's a problem? But the extra overhead of TCP slows things down, and it's more load that goes in. So there's always a balancing act that you have to go through, because there are some protocols, DNS, for example, we always say it's UDP, but frankly, it can also go over TCP. But the defaults to these faster, less overhead protocols that are in place. So.
And the command, I just finished the command. I just want to show folks, it's possible to change the port. So if for security reasons, you've got a firewall, you want to change it from the default port to another port, you can do that as well, right? So again, my question was focusing on kind of the default syslog, so UDP 514, but it is possible to change that as well to TCP and the port. So anyways, just a quick mention about that. All right, here we go. This is where things get really, really fun, although I've been having fun for the last 50 minutes. We're going to start a packet capture across this link here, right? Because I've configured the logging to send the messages to the quote unquote NTP server. So these messages on the router should be crossing this link to be stored on our syslog server at the 192.168.100.100 address. But what I want to do is I want to do a packet capture on this. And in particular, what am I going to do here? I'm going to, wrong button, this is not the, there we go, settings is here that I want. And I'm going to do, you can see I've already practiced this a little bit. So UDP port 514 is the filter that I'm going to put in place for my packet capture. So I'm going to save that, there we go, apply. And I'm going to start the capture and just, actually, you know what, I'm going to, let me just change this to like a huge number here. Just, I know I'm not going to generate 500 messages, but I just want to make sure it keeps running as long as we're talking. And so what I'm going to do, I'm going to start this capture, and I'm going to do the same thing I've been doing for the last 50 minutes. I'm going to no shut the E00 interface, and we'll see what messages are sent to the log, to the syslog server. Actually, hang on. Before I do that, I just want to remind folks that if we go back up to our show logging, which is very far, here we go. We're going to be logging informational messages, right? So up to level 6. I could have changed that, by the way, but I left it to that because I wanted to pick up a bunch of stuff, right? I didn't want just that level 3 message we've been looking at. I want to see both the down messages, both the up messages, and then I want to see the DHCP message. So I should get 5 messages from this going across to the syslog server. So E00. Oh, I'm just going to start that before I forget. There we go. So starting that capture, let me make this a little bit bigger. And you know what? I'm going to do the thing that we should always do when we do one of these. There we go. All right. So what I did there, folks, by the way, I just opened another pane, if you like, a frame, so I could have the capture on the right and what I'm about to do on the router on the left. So interface E00. I'm going to shut that guy down. It hangs for a couple of moments there as it's bringing the interface down. We're going to bring it back up again. There we go.
There it is.
And we should be getting, I've zoomed in quite a lot. So
just keep dragging to the left. Yeah, there you go.
Yeah, good point. All right, so I'm going to do that. Fantastic. There we go. I said 5 messages. Let's see. So you got 1, 2, 3. Did I get, where are the other ones?
I was answering questions in the chat that were over there.
No problem.
Did you set it at?
It's set to informational, so it should have gotten all of them, but maybe something happened here. Maybe just by moving it over, I lost something.
Yeah, something kind of got flushed in the distance there. But you've got the 6, the 3, the 5.
It should have gotten, because again, if I go back to my levels, it's set to informational, which is level 6. So I
Okay.
should have received those 5 messages. Well, so what did I get? So we have a look at this. This one went down, came back up, and then I got the DHCP message, which is fine.
And so which one are you missing?
Yeah. Well, I'm missing one for when it went down and one for when it went up. I got yeah. Okay. Anyways, if you guys practice it, you should get 5, because when I did it last time, I did get 5. 2 when the interface came down, 2 when it came up, and then obviously the DHCP message as well. So let's just have a quick look at this to kind of wrap things up, because we're getting close to time. You can see the message is pretty clear. It's a syslog message from the source to that destination, and we can have a look at these the messaging as well. If I open it up a little bit, it'll be even clearer. So we got layer 1, right? This is the frame, layer 2, layer 3, layer 4, and here's our syslog message. And as you can see, it's not a very long, complicated piece of data. That's the payload. It's giving us the actual log message, right? So link 5 change, right? Interface administratively down. It was a notification, so notice is the way it's called. And then we mentioned this way at the beginning of the session, this local 7 facility, which is really odd. Again, this is what the RFC uses to identify the facility. And as we saw, that's like the default value for the Cisco router. But we still have the information here, right, of the local iOS facility, if you like. So it was a link sub-process in the router that generated that message.
The way I always think of those is like the local 7 facility, right? That's sent to the Syslog server, and it can be used for organization, sorting, taking particular actions like on the server itself. But the local facility, or I always think of it like it's the local service that generated the message, in this case DHCP, right? That's maintained as part of the message that's in there. So it's like different purposes, right? The DHCP is relevant like at the device level. The local 7 is more relevant kind of at the centralized server level for structure and organization. So,
like you said, to be able to sort it or search it, right, for depending on the type of service or the type of facility that's been generated. And folks, those of you that will download the CML, don't forget that we've got the guide, right? The whole lab guide is in here. And way at the end, because this is where we're kind of getting at, way at the bottom here, I do get into obviously the packet capture, right? You're supposed to see 5 messages. And then I do go into a little bit more information around what these facility levels are, right? You can see there's a bunch of these local use ones that Hank was talking about. The local 7 is the default value. And you can see all these different services, if you like, within the router or the switch or the device that's generating the message that can use these different facilities to kind of identify them, if you like. Let me just go back to my panes. And I just wanted to do one last little thing here. Let's do that, show logging. So again, we didn't change anything about the level of trap messages, right? It was informational. You can see that we didn't see 65, right? Because it was trapping before, but it only sent us 3 messages earlier. So we see that. And we see that we're logging to the server, that it's using UDP 514 as we discussed earlier, and that's working correctly as well. And so that, again, just to kind of help point out where, if you get CCNA exam questions, where you can kind of gather that information in terms of what you're doing and what you're configuring for your logging.
Yeah, awesome. All right, well, great job on that, Patrick. Cheers. Much extra information, and hopefully I imagine everybody is ready to kind of answer those questions, to describe Syslog and how it fits into the architecture. We had a phenomenal number of questions that came in from chat, and I was able to keep up with most of them as went through.
But I wanted Thanks, Hank.
To just let you know a few of the ones that came through that went in. One, I actually had to claim ignorance, right? Someone asked, I'm trying to find it in the list, like, what's the difference? There it is. Which message format, RFC 3164 versus RFC 5424? The various Cisco OS's support? What's preferable for advanced parsing? I don't know the answer off the top of my head, Patrick. I don't know if you do either. But I think I wanted to call it out here because there are different RFCs that fit into the Syslog framework. Like, it's been around for a long time. There's a lot of stuff that's out there. And there are some differences that happen based on how the formatting go through. And you can have impacts, and some of that depends on the server you might be using. If you're using Splunk, it may say, hey, we request to get them in this RFC format for different parsing and pieces that go through. So it's worth kind of diving deeper into kind of your larger logging ecosystem. I did promise we'd look into the difference between these 2 RFCs and post a reply to Odak's question, or Odak Peter's question, because I think it's a great one, right, to help get to some of the depth that's in there. So,
And I spent some time on the RFC when I searched for it, and I thought there's a couple of places in the lab guide where I created a link to the RFC that I was referencing.
okay,
Obviously,
good.
now I'm looking for it and I can't locate it because when you try to find something live, it never happens.
Yeah.
But yeah, there's a couple of, I think towards the end when I talk about this over here, here we go. Yeah.
Okay.
So okay, no, actually I've got 2 links. So this is an interesting one. This is the facility naming that Cisco uses, right? And the list is massive. I mean, look at how long the scrolling bar is. It would take forever to go through all this. But then I said the other one that that I've got is usually I also had the
you need to go back in your
the
browser.
RFC. Yeah.
Navigate it away from CMO.
Oh no.
Oh no, let me log out.
Oh no. Well, anyways, we're at time, so it's okay. But anyways, yeah. So I did search the RFC the other day for Syslog. There it is. Yeah, 3164.
I want that protocol, Syslog.
Yeah, BSD. And it wasn't that one. So this one. Yeah, RFC data tracker. Oh no, here we go. Yeah, this one, IETF data tracker. And I'd gone through it a little bit, but I hadn't realized there was maybe another one. Okay, here we go. 5424 is the latest one and obsoletes 3164. Okay, so if you're referencing this, if you're trying to figure something out about the protocol itself, this is definitely the one you should be looking at, the latest version of the standard.
The general advice when there's different, particularly when one RFC comes out to replace another one, is always try to use the latest. And Syslog's been out forever. I mean, if you look at this 5424, I think was it, 2009? So it's not like this is a new RFC. Most software platforms, Syslog servers should be supporting the latest. So I generally recommend use the newest stuff.
Yeah.
But we'll take a look at it and see if we can find some of the specific differences that are in place. So.
Yeah. Sounds good. Well, thanks, folks, for joining us today for this Syslog detective work that we just did. Hopefully this will help you, as Hank was saying, with that describe task. We obviously went a little bit further than just describing. We had to look at actually configuring and verifying and investigating and trying to understand how Syslog works in a bit more detail. Yeah. Hank, any closing words?
No, great job, Patrick. I think it's always fun, right? It never fails, right? I've used Syslog for years, right? I've been in the networking. I earned my CCNA ages and ages ago. But even going through this lab with you and kind of going in, like I picked up a few more tricks, kind of looked at a few things. It's always valuable. There's never a kind of an area that we can't learn some more. So I'm sure the audience that was out there all found kind of the value that was in here as well. So thank you again, man.
And thanks for keeping an eye on the Q&A. I can see loads of messages, and you were busy typing furiously away while keeping track of me throwing questions at you. So well done for you as well. Thanks, Rigo. Over to you.
Awesome. Thanks, guys. And another great session in the bag. Thank you so much for sharing your knowledge, expertise with our audience today. I hope that everyone found great value in today's presentation and that it is helpful for your exam studies. And before we wrap up, I just wanted to take a moment to couple of quick items for you. So as we mentioned earlier in the presentation, we do have some CCNA prep resources here for your convenience. We have a CCNA prep learning map that contains a curated list of resources that will complement your core training and aid your exam learning experience very well. So we highly recommend you take advantage of that. We also have a prep practice quiz with a series of questions that'll help test your knowledge on the topics discussed today. And then also we've got some activity files for both Cisco Modeling Labs and Packet Tracer for hands-on practice. And of course, we can't forget about the CCNA exam blueprint. This is your main guide to help you prepare for the latest topics that you can expect to see when you take the exam. And again, you can make your way to these resources by scanning that QR code on the screen. But this link, the link can also be found under your Slido resources. And also, I'd like to take a moment to cover our remaining live stream for the season here. So we are down to one remaining session for this round of live stream events. The next and final topic is in 2 weeks on Thursday, May 1st. So we have Patrick and Hank. They're going to be back to wrap up CCNA Prep Season 2 with SNMP. We hope that you can join us for this last live stream. If you haven't done so already, you can go ahead and register for the prep program to receive email reminders. You can also easily add these sessions to your calendar. Go ahead and scan the QR code on your screen to register for the prep program. You can also use that link provided in the Slido resources as well. Last but not least, we have launched a survey in Slido, and we would be so grateful if you can just take a moment to complete it and let us know how you like today's presentation. We always look forward to receiving your valuable feedback. Once again, I want to thank our presenters, Hank and Patrick. I want to thank all of our attendees for joining us here live. I hope that you enjoy the rest of your day, and we hope to see you next time on the Cisco Learning Network. Thanks so much, everybody. Have a good one.